So thanks for having us. We appreciate some agenda time on this topic. We're going to talk a little bit about DOCSIS today, and we know that may not be the front of mind topic for a lot of folks. So we'll come into what DOCSIS is about and how some of the cable operator networks work, just to bring everybody to the same moment, and we'll move forward. We'll move forward then into how we tried to bring that into SEBA a little bit. So I'm Chris Busch. I work for CommScope. I'm a fellow in the CTO office, and a lot of my role is around how can we help our customers along their journey in virtualization and how they transform some of their currently converged network architectures into distributed and in some cases disaggregated. And Jaspreet?
So Jaspreet, so part of CommScope Global Services. Our main goal is partnering with operators, making sure we deliver solid software solutions involving automation and orchestration.
Excellent. So a little bit of that background for the cable industry, where the cable operators are, what they're currently investing in, and a little bit of where they're going. So today, typically, we'll find, and Alad showed that this morning in the keynote, we have these converged cable access platforms, these really big chassis, and they live in hubs and head ends. And they terminate a good number of subscribers, maybe 40,000 customers behind one of these boxes here. And I think Alad also mentioned that today, the distribution goes out maybe 10, 30 kilometers out to a node device, right? So this is an active device. It's in the network. And how it gets there is there's an analog laser, right? Forward and return, or downstream and upstream, that's bringing that signal out to that active node element. That device will reverse that process, right? It'll take the optical, put it back into electrical, and then eventually goes down the line and into your home as a coax connector. And so that's how delivery, fundamentally, of voice, video, and data in a cable operator system will work today at a very, very high level. And the operators have a lot of choice and flexibility in how much bandwidth they can make happen over DOCSIS today, even with the integrated systems. And there's references here along the bottom of the chart, and we can talk about them offline later. But it really refers to how many steps of amplification, how many elements essentially are in the total span or cascade for the service of this one group of cable modem customers before it reaches the end of the line. And so when you want to, let's say, double your bandwidth, you will segment this node. So as Alad mentioned, you go send construction crews out, field crews out, and you'll go and essentially have the number of customers consuming the same amount of resources, thereby doubling the bandwidth effective to the customers in return. Now, the operators are on a really neat journey. So Cable Labs, organization behind a lot of the standards that help drive many of these systems, they said, well, we could distribute a lot of the actors that are inside this chassis, this CCAP core chassis. We could move some of their functions out into these node devices. So the first one that was up was moving the PHY modulation. So today, these boxes will have F connectors on the back, right, that present themselves into that optical transmission. Well, those F connectors come out, and then they show up down in the node, 10, 20, 30 kilometers away. The optical transport becomes all digital now. That's a fantastic gain for the operator because it returns a ton of optical domain for use for any other kind of digital service, right? And so upper C-band and L-band all now available for DWDM, CWDM services, whatever the operator may choose. And some operators will also bring into the same path, they'll bring in PON services as well. There's certainly ways to mix and match that into place. Now, you may have said, okay, I get that there's a benefit, okay, in the optical domain. Why do operators want to do that? Well, it's a stepping stone, right? It's a big enabling moment in the architecture for a couple of things. One is these nodes now can be more easily distributed into that cascade line, as it were, right? You can go and revisit that front of the line node that already exists and just upgrade it to a Remote PHY. Or you can fiber overlash and go down and split that cascade quite easily, right? And so you've got a lot of flexibility now in how you treat those customers. And as you do that, you're effectively adding more and more bandwidth to the mix. But also, you're lowering a lot of the noise contribution and artifacts that are in the RF system. So you're now able to do some really neat things like introduce full duplex DOCSIS technologies, or even extend the upper bands of the RF technology that you have access to in many of your DOCSIS chipsets. So you're getting more bits per hertz per second down the same coax connector effectively by going to a distributed architecture. But the moment you did that, that MAC core is sitting in that chassis. That MAC core is just a compute function now for subscriber IP service, policy, and security means. So effectively, it's a stepping stone that also enables virtualization. And lastly, there's, for the cable folks, there is a PON architecture today that they favor, and that's EPON. And the reason the cable likes to favor EPON is because, well, cable labs work together with the industry on doing DOCSIS provisioning of EPON networks. So DPoE services are a pretty big deal for cable operators because it inherits their back office of how to bring on a cable modem and how to count subscriber consumption data in things like IPDR records that are then emanated by DPoE systems. So there's lots of options for the cable operator to basically keep going from 1 gig to 10 gig and even further down the line. And how that looks kind of in a more high-level slide is, well, we talk a lot about central office re-architected as a data center. So we sort of think this is a bit of the journey of the operator from that integrated CCAP chassis in linear transmission, going out to a node, and then eventually to your house, to introducing a leaf and spine digital transmission network that has a split approach of MAC processing up in the head end and remote PHY functionality that's deep into the network. But that's that stepping stone moment. We call it a vCore CommScope, but it's a DOCSIS VNF. It's a MAC core processing that's now running in x86 processing or any other processing platform potentially. And so it's that final stepping stage that then comes down to what some might call head end re-architected as a data center. Right? A lot of the actors start to look, act, and feel the same between the different standards, as it were. Oh, there's the segue. Thank you, Jaspreet. So we sort of looked at this idea of bringing DOCSIS into SEBA, and we really came to the opinion that the PHY shouldn't matter long term, right? Whether that's XGS PON, GPON, remote PHY DOCSIS, 5G backhaul of some kind, the PHY shouldn't matter. This should really be more about a service that's modeled, right? And then executed as a graph across the dependencies. The actors that the cable labs driven systems for distributed access that were identified, gosh, they look exactly like what SEBA's doing today, don't they? Right? Service functions up top, sort of a cloth, leaf, and spine topology down below, and then insert PHY here, right? So we had a tier 1 customer ask us a question. We're not allowed to say who. Darn it. But they said, well, we want to orchestrate services regardless of the technology. Right? So we'd like to do top-down modeling, right? Execution of a service graph. How can we deploy DOCSIS DAA and also do PON in VOLTHA? And so in fairness to this operator, one of their big motivators was where they are in the world, they have a lot of 5G advanced competition. And their belief was for the speeds and feeds that account for the greatest number of residential subscribers in bandwidth terms that could easily be served over 5G in a fixed wireless access capacity. They feel that to compete and to be effective as a business long term, they need to have the agility and low cost that comes from well-defined interfaces and standards that have brought velocity to their business and lowered the cost of the equipment. So they feel that the wireless operator, moving from 4 to 5G, has that in their standards, right, and in their interfaces that have been defined. And if the bulk of their customers are taking a 30 meg or 100 meg product today, that's something they were very concerned that if they didn't have the same velocity in their wireline network assets, that they would be at a competitive disadvantage. So they said, well, this remote PHY device, all right, we get why it's there, and we just talked about a little bit how it came to be. Why don't we just disaggregate it then? Because that worked for PON, right? So let's disaggregate that and get all the vendor stuff out of the way, and then we can move faster. Well, that sounded scary, and for the reason that it's actually, the reason we wanted to do disaggregation in PON networks was because we had a vendor lock-in of sorts where the OLT manufacturer was prescribing the ONT or ONU device right at the end. But Cable Labs has the reverse, right? Cable Labs systems and standards, interfaces, data models, they all exist to ensure the preservation of interoperability among vendors, both in CPE terms and core terms. And so if we removed the Cable Labs personality from this, we would effectively be creating a lock-in solution. And that would be wrong. because it would be a remote PHY that would become disaggregated that would only work with some bookended core somehow, somewhere. So instead we said, well, why don't we look at how we could reuse some control plane that comes from Cable Labs that's in every remote PHY device that's manufactured by every vendor on the planet today, and that way we know it'll work with every core. So that's how we started to approach this. So we'll move quickly because I'm sensitive to time, because I'd like Jaspreet to take us through a little bit of what the code did in further detail, but just want to get folks into an RPD and how it comes into the network, and why does Trellis just feel like a nice warm glove to remote PHY. So there's a 10 gig optical link that comes out of each one of these RPD devices. Again, we got rid of that linear AM transmission and went all 10 gig digital optical on a wavelength. So when we terminate that, we bring it into something we call an S leaf. The S is for secure. And I guess it might be a cable term, but it's simply by virtue of using MACsec at the leaf device. And Trellis is sort of not exactly first-class citizen with MACsec, but there's a way to get there. But in any event, it is optional to use MACsec. Either way, one of the key actors here is you start with .1x authentication. That's well understood in Trellis today. So we'll do that with a Cable Labs root certificate out of the RPD device, and then through Radius coming back with an access accept, we'll start passing traffic. So the first stage traffic after that will be DHCP. Now for Cable Labs, DHCP is almost used like a control plane, right? The standards say we need to do device identity through client options that are included with any Cable Labs specified type of device over DHCP. And we also like to do direction, right? Or discovery of what you need to do next through the offer or the solicit response in DHCP in Cable Labs terms. And that happens here in RPDs. RPDs will send out their client 60 option that says, hey, I'm an RPD something, something, something in their string, right? And that's the first hint for DHCP to know what kind of device they're dealing with. But then in response, they're looking for DHCP to tell that device where is their core that they need to connect to. So that core connection occurs over this new protocol that was introduced by Cable Labs called GCP, Generic Configuration Protocol. It wouldn't be a good ONF show if we didn't have a lot of new acronyms, right? So this GCP conversation comes in, and the simple way to think about GCP is how many people have cable modem high-speed access at home today? There's no DOCSIS customers in here? We gotta go. Okay, we've got some. Okay, good. So Rob's here. Rob's gonna be like, what the heck? You better not be in a Comcast market. So your cable modem today takes a binary configuration file that has, probably on the order of maybe 200 TLVs encoded into it. It reads that in and says, oh, thank you for telling me what I need to do with my life. Lights go green, right? GCP is like a cable modem configuration process, but just like juiced up a little, right? Same binary configuration struct, right? You've got ASN1 data, it goes down, but you maintain an RPC now, right? So that's GCP in a nutshell, and we wanted to really exploit that we could get into RPDs on an ongoing basis that way. So attaching the RPD in high-level Trellis terms, gosh, there's that packet in. So we get a lot of good LLDP love right at the get-go. The AAA process is an SDN app out of ONOS today. The DHCP relay, SDN app out of ONOS today. And unbelievable richness out of the message bus. This is like next-gen assurance, right? For those who really love and care about their network, message buses are your friends, and they just come for free with Trellis. So onboarding is pretty simple. The fabric, you get your segment routed topology out of Trellis. Again, you've got through route server enabled leaf pairing, you get in and out of the RPD survivor island here on Trellis, right, out to the rest of the IP world. Multicast traffic is a pretty big deal. In the HFC network, our video traffic was combined, right, electrically, and then delivered down, right, in frequency allocated bands, right, obviously away from the data. Well, that RF portion at the final edge is still the same in remote PHY, except that remember, there's now a 10 gigabit Ethernet optic going down to the device. So the delivery of the video in broadcast terms is a multicast, right? So Trellis will get that down to us as well as our DOCSIS data. And then we get this decoupled message bus. And we're still dependent on DHCP. We still have to have this, oh, that sounds like an RPD device. So I'll figure out what to do with it from there moment.
All right, so let's talk about how SEBA fits in. And so we started looking at SEBA and looking at all the layers and seeing, okay, what would be all the affected portion of SEBA in a DOCSIS environment for DAA. Obviously, the very top, the service instantiation, the service graph. You've got today service graphs for different workflows, AT&T, Turk Telecom. So those need to be changed, right? Those need to now become RPD aware, hopefully agnostic still, so that we can have agility in creating those services. So we still want, if you looked at the DOCSIS picture, right, there's a many-to-one relationship, right? So it's not a one-to-one relationship from a subscriber perspective. So how ONU, OLT to the Fabric Cross Connect to a BNG, that's almost a one-to-one, and in a subscriber perspective. So for an RPD, you've got many subscriber talking to an RPD. RPD then talks to a cross connect, a Fabric Cross Connect, and then on to a vCore. That's the vision, what SEBA should understand about that. And one of the other things is the VNF. vCore, we talked about vCore, the virtualized CMTS. That now needs to be managed natively in SEBA. From an inventory perspective and from some of the services perspective, there's almost you can look at similarities. RPD is now looking as a virtual OLT service, and vCore, like I covered already, is looking as a virtual BNG, right? So, when you're starting with something new, it's try not to change too many things, so we try to keep those concepts in mind. VOLTHA is pretty extensible, so we thought, okay, well, an adapter would fit in right in play, and we'd be able to extend that. We also want the ability to reach out to other config management system, right? To be able to say, well, I got inventory in my CommScope's vManager tool, so I should be able to dip into that. So digging a bit deeper, right? So looking at how what Chris talked about, the DHCP comes up. DHCP tells you the IP address of the GCP adapter, and then off you go. The biggest gain of what VOLTHA is now doing is we really need to view this as a complete access hybrid system, right? It's still very PON centric. So what VOLTHA allows you, if you look at it from a very high level, is it's a logical switch. So instead of the ONU OLT combination, think of that wrapped into one box, which is now an RPD. So you got a uni port, which is your subscriber, and an I port to your Fabric Cross Connect. That's what needs to happen, and VOLTHA allows you to do that. We were talking to Sean that maybe we should change the name of VOLTHA to something else. If we give back to the community, it becomes becomes non-access oriented, right? That's the spirit. I think I touched on most of those things. But essentially, there's few challenges here, right? So for example, we talked about the mapping from the Fabric Cross Connect to a vCore. Well, it's good if it's static, right? Mostly I can create a service graph. You can instantiate it. vCore will come up in a Kubernetes pod. You know it's egress port. Off you go, right? The ONOS knows about it, learns about it, be able to route traffic. Well, what happens in some cases, maybe you need to scale up your vCores, and now it's getting a dynamic mapping. So we need to be able to manage that, right? So, what does the SEBA pod look like, Chris?
Well, someone let me loose with the PowerPoint paintbrush, and I thought, wow, if we only had more rack units. So there was an interesting presentation yesterday that discussed the opportunity to utilize spare pluggable optics ports for other purposes. And so what we've shown here, we've just said, well, if you had dedicated rack units for XGS PON, then this would look pretty much the way this kind of rack looks. But you could also say, well, look, I may have lower take rate or lower home pass capacity hubs in my network plant. And so maybe these, well, Cable Labs folks would term S-leaves, right? These leaf switches, maybe they're actually mixed mode operation, right? They're both PON and RPD service endpoints in the network. The big enabler here is the fact that we're able to execute whatever the personality is of that port, right, as a directed service graph by using the SEBA technology. And for us, I think Jaspreet pointed out, for us, we treat our data plane VNFs on our Kubernetes cluster for DOCSIS purposes as, well, they're outside of the SEBA pod today, but that's an opportunity for something in future.
Right. So today, like I said before, that you want to be as close to parity with the solution support. So you have BNG being supported as an external device, perhaps being embedded. In our case, we think of it as a VNF, and treating it as a separate Kubernetes cluster may be the first option. But why not roll that up into the same Kubernetes cluster and manage the same one cluster to manage all your VNFs? That's a possibility, right? There's something out to the community. So how did this really look like, right? So for example, GCP init, the init message comes in. We actually leveraged some of our products. So we took a GCP stack, and that's the reason you see the RPD redirector as a separate service. We started with a simple VOLTHA adapter, which was essentially listening on a port to say, hey, GCP registration would come into this, right? So essentially all it did was open a specific port, 1881. And really there's no reason for them to be separate, just different programming languages. We thought it's best to keep it separate at the moment, just it was faster to develop. So request comes in, we take a look we dip into our inventory, which by the way could be built into NEM. Due to time, we couldn't do the direct integration into NEM for inventory. As a result, it now knows, okay, what's the vCore address of that RPD? Okay, it then it registers to the vCore adapter, or sorry, the RPD adapter in this case. This is a little older slide. So that's simple post message to say device is here. It's plugged in. That sends a packet in message to ONOS. You have a pretty graph showing up in ONOS as a full logical switch with ports, and you are now off to the races, right? So that actual work, it was very fast to do, right? It wasn't like it took, this was a fast turnaround. So we now actually have, I know this is hard to see, you now actually have a adapter type RPD in the repository. You're able to pre-provision in RPD just like you would pre-provision in OLT. You've got your devices listed out with the UNI and the NNI ports that are connected, right? As a result, when these get plugged in and registered, it sends an ONOS open flow command. You got your switch registered, right?
So we had a few thoughts. So this was first, if it wasn't obvious, this was our first go at working with VOLTHA and standing up SEBA, and as Jaspreet said, we worked hard to minimize the moving pieces so that we could achieve a measure of success and take learning back and to try to figure out, well, what would make sense for the right next steps. We think some of those may be, well, first off, make this a proper and contributed VOLTHA 2.x southbound adapter, right? So move the GCP speaker in as a native VOLTHA adapter. But then, you should say principal core. It says aux core. That's probably my typo. But extend it from just doing redirect. So we've said the word redirect a few times. It's very intentful. There's a portion of the standard that lets you literally send a redirect message type, which is, again, a TLV 25.1 for those of you looking to write the test after, right? So, and you could, instead of redirecting the device, which gives you all that good knowledge of where is it in the network and where is it going to go in the network next so that you can build an intent and do all kinds of good stuff, you could instead hold state with the device. And we think that's where it gets cool, right? Because we maintain a GCP socket with the RPD, then we become the provisioning, so VOLTHA becomes the provisioning actor for the RPD devices, which now means we have ongoing telemetry of what's happening at every layer of the RPD. Inside the L2TP tunnel that RPDs launch to their core for either video or data service are pseudo wires that carry directionally appropriate traffic, meaning there's a pseudo wire called a DEPI pseudo wire for downstream RF channel content, and there's a UEPI or upstream pseudo wire for upstream. That's forward and return right there. And you put a whole bunch of them together and you have yourself DOCSIS data inside of an L2TP tunnel. You can gain all of that state data by using GCP. Otherwise today, cable operators have to ask for it over SNMP to the core. So this would be a lot more fun because it would go right out to Kafka. So we think that could be a big gain. And then Jaspreet, as you were mentioning about the life cycle.
Yes, so really looking after that vCore, the VNF really that's DOCSIS aware to be able to manage it, right? So for example, manage it in multiple ways. In a Kubernetes that is a cluster that's away from the pod or a cluster that's managed within it. But essentially, SEBA managing the VNF natively is our goal. That's what we're going to be doing next on this. Talking about NEM and XOS a bit more, taking those services and actually now implementing it. We didn't get a chance to do it this time around. We hope to present that next, where we actually have a full end-to-end service instantiation of an RPD device to a cross-connect to a vCore, right? So hopefully we have a workflow for DAA in SEBA repository, right? So really give SEBA a personality that it is truly, access agnostic, right? So that's the goal.
And when you kind of add up the sum of all the things that you've heard here for the past 3 days, it would put SEBA squarely in the definition of all wireline and wireless access mediums, right? We've heard from other presentations about having a role for SEBA in 4G evolution into 5G, in possibly front haul type scenarios, talking about extending SEBA in EPON ways, in GPON ways, and SEBA in addition to XGS today, and now DOCSIS. It's a very interesting time, I think, for the project. So yeah. I think with that.
Yeah, thank you.
Thank you.
Any question?
Yes.
Can you pass the
Oh, yes.
Thank you. Could you please go back 2 slides? Yeah. One before this, please. One more. Yeah, this one, sorry.
Yeah.
So the bottom, the last screenshot there, verify device, UNI and NI. So what physical port does port number 2, which is labeled as UNI port, represent?
Yeah. So
You probably, yeah. Yes.
So you can think of that UniPort as, if you were to physically think about it, it's the RF-facing port of the RPD. But that's a very interesting port because, remember, the MAC processing is happening in the core. And so whether that core is physical or virtual, right, that's where the MAC is. So the knowledge of the subscriber relationship, like Jaspreet was mentioning in PON terms, there's no ONU to ONT or OLT to BNG in this, right? We kind of have this abstracted ONU that we can't quite see, and it just like materializes up at what is essentially the BNG or the core for DOCSIS. So the way to understand data behind that uni is actually to implement the full GCP principal service to maintain state with the RPD, and then to do a come-around interface to the core and map the associated DOCSIS cable modem devices that would then generate UniPort stats and so forth, counter logic that would complete the visibility.
Would you be so kind to show the last slide? That one. So the question is, how come you opted for moving GCP into VOLTHA 2.x as an adapter and not using OpenOLT, which would kind of separate even more the layers? Not having to use to deal with VOLTHA, but to do it all the changes inside your system and not in the cloud.
That's a good question. Sorry. You mean OpenOLT as an adapter, native adapter in VOLTHA? I think I think maybe just our understanding of it. This is our first time looking at SEBA stack. We thought it'd be better just because we were leveraging an existing GCP stack, right? We thought, okay, well, instead of putting all that GCP logic into something that was pre-existing, let us create something new, something dumb, which is a simple listener and the GCP stack at an arm's length. That was really it was just an engineering dev time issue.
Last question?
Is this on? I think it's on. Okay. Yeah. So I guess just to follow up on the whole OLT ONU analogy. So when I think of cable systems, I think of I've got a cable modem in my house, right? So and in the PON implementation, there's an OLT and then there's a ONU. It seems like there's a similar analogy here where the remote PHY device is kind of like the OLT, and then the cable modem is the ONU, and the GCP is the equivalent of the OMCI. Is that the model? Like so
Yep.
that
Yep.
so there's the cable modem. Why didn't that exist as a managed entity? I guess.
Yeah, so it might be a little bit of an answer similar to Jaspreet's last answer, but for us, the realities were by kind of leaving the cable modems as this sort of opaque actor. If we didn't, then we would be designing in interfaces that would have to account for their state up in the core. And then we would probably be becoming more involved with, well, what is the configuration nature of those particular devices? Those devices would have a DHCP-centric configuration process to be followed. It'd be hard to put information about that into SEBA, at least in the amount of time that we were working, this proof of concept up with. But I think those principal tenets of what would that actor represent itself out as in the next stage term are very much at the heart of what we're looking to resolve next in the design, to get it. So now that lots of folks are sort of hearing it, saying, well, did you think about this, or maybe would this work better, or hey, we've done a lot of other work in SEBA and we follow this pattern, I think we'll understand better how it might fit going forward, if that makes sense. Yep.
And then we have associated technical profile associated with the service.
Yeah. And right in there is part of it was like the third rail we didn't want to touch. So to your point, the tech profiles is like a service class name configuration in a CCAP system. And then inside the configuration of the cable modem, there are upstream classifiers that will lock that cable modem's config to that service class in the CCAP, and that's how you get the differentiation of this customer gets 100 meg, this customer gets 1 gig, for example. All of that is so external from this. How could we make a tech profile? Work to be done. Yeah.
Okay.
Exactly. Yeah. And we were trying to sort it for ourselves too. Yeah.
Thanks, CommScope, for this presentation. And I think one comment on the SEBA and VOLTHA's presentation. We always include DOCSIS or DPoE as one of the potential technology we need to support.